So the final topic which we'll be seeing with respect to e-learning with respect to the introduction to machine learning course is reinforcement learning. Okay, so in this couple of videos we'll be walking through the thorough information about reinforcement learning. So basically reinforcement learning is a feedback based machine learning technique in which an agent learns to behave in the environment by performing the action and seeing the result of action. So for every good action, the agent gets a positive feedback, and for every bad action, the agent gets a negative feedback, or you can call it as penalty also. So basically, this is like a kind of trial and error. Okay, so trial and learn actually. So whenever you are doing something good, okay, it takes a positive feedback and it should do more often of such things. So, or more often with respect to such approach. And when it is a negative feedback, so basically whatever action you have done is bad, which should be avoided. So maybe the machine will try to find a newer pattern so that it can find a better one. So basically it is more like a robust thing, and also with respect to it is kind of an artificial intelligence which will try to improvise itself on daily basis also. Reinforcement learning, the agent learns automatically using feedback without any labels, okay, unlike supervised learning. So it does not need any label data by just taking the feedback. So it will just read out what exactly was the outcome and whether it will uh, check with respect to whether it is a positive one or negative one. So since there is no label data, so that the agent is bound of learning on experience only. Okay, so it will learn only on experience. So a little similar with respect to unsupervised learning when it comes to no labeling, and also with respect to reinforcement learning, it solves a type of problem which is like decision making and sequential. So again, the goal is also the long term, like such as building of robotics, or game playing, or training a bot to play a game. Okay, so the agent interacts with the environment and explores by itself. Okay, so the primary goal of the agent in reinforcement learning. So here basically we are not calling them as model. Okay, so when we were looking at supervised, unsupervised, and semi-supervised also, there we will be having models. Okay, so those are the models which will be trained up, but when it comes to reinforcement learning, it is the agent. Okay, so the primary goal of the agent in reinforcement learning is to improve the performance by getting maximum positive rewards. Okay, so the agent learns by hit and trial method. So basically I think we have few more insights before going with respect to the uh, terms used. So basically hit and trial method. So based on experience, it learns to perform task in a better way. So hence reinforcement learning is a type of learning method where an intelligent agent, okay, it is an intelligent agent where this again agent would be nothing but our computer program, interacts with the environment and learns to act within that. Okay, so basically with respect to a positive feedback or with respect to a negative feedback. So example would be a robotic dog learning to move his arms and legs is an example, right? So again, it is similar to like reinforcement learning is similar to artificial intelligence. So it is a kind of a core part of the AI. So the agent can also be called as AI agent. So it works on the concept of reinforcement learning. So here we don't need to pre-program the agent. So it learns from its experience without any human intervention. So again, suppose there is an AI agent present with a maze environment. Okay, so the goal is to find out the like maybe some kind of end route, exit path. So the agent will interact with the environment by performing some action. So probably moving forward, backward, and checking whether there is any deadlines. Okay, so dead ends. So when it hits any dead ends, it will try to move on with respect to the alternative path. So this is how it will trying to completely memorize the map itself. So with trial and error, okay, positive reviews and negative reviews. When you are having the complete all the positive reviews, and the you will be reaching the end goal of exiting out of the maze, and the agent the agent interacts with this environment by performing some actions, and based on those actions, the state of the agent gets changed. Okay, it also receives a reward or penalty as feedback. So the agent continues doing these three things. Okay, so those three things are mainly take action, change its state, or remain in its own state. So if it is positive, whether it is doing a positive or maybe a good decision. So at that situation, it will stay same, and if it is taking a bad situation, then it will change its state, and finally it will get the feedback. Okay, and by doing these actions, the agent will explore the environment. So agent learns that the action leads to positive reward or positive feedback or rewards, and what action leads to negative rewards or penalty. As a positive reward, the agent gets a positive point, and as a negative reward, as a penalty, it will receive negative points. Okay, so the common terms what we come across using reinforcement learning. So agent is a lot about what I just spoke about. So an agent is an identity that can explore the environment and act upon it. Okay, so that is what is an agent is. And also with respect to the environment, so a situation where the agent is present and surrounded by, and in reinforcement learning we assume the uh, stochastic environment, which means it is random in nature. Okay, it is not the exact same following pattern and all. So the more random it is, the better the agent learning curve would be. And the action, okay, so this, the step where the agent will take at the very beginning. So actions are the moves taken by the agent within the environment. Okay, and next we have state. So state is a situation returned by the environment after each action taken by the agent. Okay, so that is like a good decision or a bad decision, something like that, good step or a bad step. And reward, okay, so this is the feedback which will be returned to the agent from the environment. Okay, so to evaluate the actions of the agent. Okay, and next we have policy. Okay, so policy is a strategy applied to by the agent for the next action based on the current state. Okay, so whenever it applies any kind of action, so it will be changing its state or remaining in the same state. Okay, so based on the current scenario or the current state which is it in, a policy is the strategy applied. Okay, so basically it will use a strategy known as policy to take next action. Okay, so next action based on the current state. And we have value. So it is expected in terms of long term, right? So long term return and with a discounted factor. So opposite would be and opposite to the short term reward. Okay, so it won't be getting a short term reward, it will be taking very long term. So again, learning wouldn't be any with respect to human intervention. It will be completely by the machine itself. It will be learning on its own by with thorough experience from the environment. And finally, we have Q value. Okay, so it is similar to value itself, but here it takes additional. It takes one additional parameter as a current state. Okay, so it is not just with respect to the long-term benefit, but also with respect to the current state action. Okay, so now we'll see key features of reinforcement learning. So in reinforcement learning, the agent is not instructed about the environment. So there is no insights given to the agent about the environment and what action needs to be taken. Okay, so nothing is instructed for the agent, the starting action or whatever initialization. Basically, we don't initiate any action to the reinforcement learning. So it is based on hit and trial process. So it will always hit or take action, and with respect to trial means it will just get back the feedback and also change its states with depending on the positive feedback or negative feedback, or you can consider them as a good decision versus a bad decision. Okay, and the agent takes the next action and changes state according to the feedback of the previous action. Okay, it is not the present action, so that's why we have action performed even before the feedback has arrived. So basically the feedback from the previous state or the previous action is taken and it will be like either it will remain in the same state or it will change its state based on the feedback which is received in the previous action. Okay, received for the previous action. And the agent may get delayed rewards. Okay, so again, you might not sure whether how good the positive is. Even if it is positive, it might not be having a huge impact with respect to improving with respect accuracy and all, since environment is always uh, random. Okay, so because of this uniqueness, it has to has continuous learning. So hence the reward might be delayed with respect to the for the agent, and the environment is stochastic, and the agent needs to explore it to reach the to get the maximum positive rewards. Okay, so these are the key reinforcement learning. So next we'll see with respect to approaches in the implementing reinforcement learning. Okay, so there are basically three main ways to implement reinforcement learning in machine learning. Okay, so first is value based. So the value based is about to find the optimum value function. Okay, where the maximum value at a state under any policy. So therefore, an agent expects long-term return at any state under the policy. Okay, so that is about value based. We have policy based. So policy based approach is to find the optimum policy for the maximum future rewards without using the value function. Okay, so there won't be any use of value function over here. And in this approach, the agent tries to apply such policies that action performs in each step helps to maximize the future rewards. Okay, so it will take steps with respect to the long term perspective, not the short term rewards or the short term positive feedbacks. So again, we have few more points about policy base. So basically, the policy base has again categorized into two mainly. So one is deterministic and other is stochastic. Okay, so deterministic means the same action produces is produced by the policy at the same state. Okay, so same action is produced and probably you will be getting back the positive feedback. So hence the same positive feedback will be coming in. Okay, and the other is stochastic. So here in this policy, probability determines the produced action. Okay, so it is based on the probability of getting with respect to a positive feedback or with respect to a negative feedback. So value based, policy based, and finally we have model based. Okay, so in model based approach, a virtual model is created for the environment, and the agent explores the environment to learn it. So there is no particular algorithm or any kind of solution provided over here for this approach, because the model representation is different from each environment. Okay, so the environment might vary uniquely, or there might be some similarities too, but it is always different from each other. Okay, so it is a rare case of having two or three similar, but still ultimately when we have a lot of difference, so that's why we won't have any particular algorithm or predetermined steps to be given with respect to the agent. Okay, so it has to learn on its own. So I think that is a quick introduction about with respect to reinforcement learning. So again, we have few more topics to cover up with respect to reinforcement learning. So before that, again, with respect to the approach over here, also we had seen the terms like policy and all, right? So there are basically a few elements of reinforcement learning. Okay, so the reinforcement learning has something like policy. So first is the policy. So policy can be defined as a way of how agent behaves at a given time. Okay, so that would be policy. It maps the perceived state of environment to take action or actions taken on those states. Okay, so it perceives the state of the environment, and a policy is the core element of the reinforcement learning, as it is alone and can define the behavior. Okay, so only because of the core elements it can completely define the behavior of the agent. Okay, so in some cases it may be a simple function or a lookup table. Okay, so basically lookup table just store away with respect to the current states and the positive reviews what has just been received for the appropriate action. So whereas in other cases it will be involved in general computation as a search process. Okay, so it could be deterministic or even a stochastic policy. Okay, so that is about policy, and we have reward signal. Okay, so the reinforcement learning is defined by the reward signal. So at each state, the environment sends an immediate signal to the learning agent. Okay, so this signal is known as reward signal. So the feedback, whatever you get. So these rewards are given according to the good and bad actions taken by the agent. So all the decisions with respect to good decision, whenever I tell decision, it has decided to take certain kind of action. Okay, so good decision means good actions are taken, or bad decision means bad actions are taken. So the agent's main objective is to maximize the number of rewards for good action. Okay, so good action with respect to a positive feedback. The reward signal can change the policy, such as if an action selected by the agent leads to a low reward, then the policy may change to select other actions in the future so that it can again maximize or improve the higher rate of the positive feedbacks. Okay, and with respect to value, we have value function. So value function gives information about how good the situation or the actions are, and how much rewards an agent can expect. Okay, so the reward indicates the immediate signal for each good and bad actions, whereas a value function specifies the good state and the action for the future. So the value function depends on the rewards, as without a reward there could be a no value, right? So hence value needs to have a reward. If there is no reward, ultimately the agent might not be motivated. You can consider in that way to take any further actions. Let it be a good action or a bad action. It does not matter. Okay. So the goal of estimating values is achieving more rewards. So and finally we have something with respect to model based, or so model the last element in reinforcement learning. So here which mimics the behavior of the environment. So model will mimic the, it's a virtual model, right? It is created for an environment so that the agent can explore. Okay, so again there is no particular solution or algorithm given. So with the help of the model, one can make reference about the environment, like how the environment will behave. If a state or an action are given, then the model can predict the next state or the reward itself. Okay, so if the model if the agent is able to predict, okay, with the help of model, that the next state would be a positive one and I will be like a good action, and the reward would be a positive feedback. Okay, so that is how the prediction will be done, and the model is used for planning, which means that it's a way to provide way to take a course of actions by considering the future situation. Okay, so it is just like training, maybe practicing something behind the scenes before you get into onto real ones. Okay, so something like that. So these approaches for solving reinforcement learning problem with the help of the model, and the like again term is based on like the approach is known as a model based approach itself. So comparatively, an approach without using a model is called as model free approach. So all the policy based or value based is actually called as model free function. Okay, so maybe a quick insight about how exactly the learning works. So basically, again, we had the same example, right, with respect to a maze. So it will take action, it will change its state based on the previous feedback it has received, and it will receive the feedback for the current taken action. Okay, so it continues until it is self improving. Okay, so there might be never a stopping of it. Okay, so that is how training of it is done. So I think we'll have a pause with respect to this video in terms of reinforcement learning, and in the next video we'll continue with the topics of reinforcement learning.